Hi, welcome back to CoffeeShop Astrophysics talk on extraterrestrial life. I'm Mark Poe. In this talk, we're going to be covering specifically what kinds of life can we find in our solar system and just beyond. So, the best candidates that we've had so far, we've observed that there are moons that exist around Saturn and Jupiter that are strongest possible candidates that may have some form of extraterrestrial life, right? So we have, let's go to Jupiter first. We have Galileo, a probe that Alex talked about in the part 1. It observed Jupiter's moon Europa, and what we saw was that Europa actually had magnetic fields around it, and those magnetic fields were consistent with motion of salt water. And so there might be actually a saltwater ocean underneath the icy surface of Europa. And similarly to that, around Saturn's moon Titan, we also believe that there's a possible salty ocean. We also have seen on Enceladus, Saturn's moon Enceladus, that, well, at first it just looked like it was just completely covered in ice and there was no activity. But we eventually saw, I think it was Cassini made the observation that there are geysers that are erupting on the poles and they're shooting water vapor into the atmosphere. And so that suggests that there is some geothermal activity and there is, more importantly, liquid water, as well as, warmer temperatures. And so with those conditions, we can possibly get some life. So what kind of life would we maybe find underneath these surfaces of ice? Well, it's unlikely to be, a humanoid. I mean, maybe something similar to what we've seen in Star Wars, but I don't know. More likely, it's going to be a microbe. There's always a possibility that exists that you might find something like a shrimp or a fish. But I think almost definitely if we find life at all underneath these surfaces, it's going to be microbial. So those are super fascinating, and I really look forward to seeing what we can discover underneath those ice surfaces. But what if we were trying to look for something else, like intelligent life? Maybe that's not the best place. So we want to look outside. So maybe we can find something on exoplanets. Well, what is an exoplanet? Well, that's any planet that exists outside of our solar system. Some exoplanets, most of them that we've discovered, orbit stars. So they're trapped in orbit around a star. A lot of them in orbit around a star with other planets. So there are solar systems that exist where they have several planets. Some of them are rogue. Some of them are just traveling across the galaxy. The ones in orbit are the ones that we're most interested in because we can periodically observe them and we can determine if they're in what we know as the Goldilocks zone. That's just this zone of habitability. It has to do with how far is the planet from its host star and how much solar radiation is it getting from its host star. And so you can actually, if you're interested in this topic, you can find out a lot more about it by going to one of our earlier talks by Gabe and Ali. They did a whole thing. They did a whole multi-part series on exoplanets, and I recommend it. So just briefly talking a little bit more about it without going into too much detail, we have found planets that very likely have liquid water. We've found, I think, a total of around 4,000 exoplanets so far. A good number of them are inhabitable zones, and so those are really useful to look at. I think also we found, it's estimated that around 1/5 of all the stars in the galaxy have planets in the habitable zone. Next, so if these exist, and if possibly on a planet in a habitable zone, what if there is a possibility of intelligent life? So there's a man named Enrico Fermi, and his paradox that he presented was, well, if intelligent life exists, why haven't we detected it yet? And it's a valid point because one of his main arguments was the universe has existed for long enough, and at least our civilization has developed to this point in such a short amount of time that we should have been able to see light or signals from other intelligent species from distant planets already. Well, I mean, and that's including, by the way, that is including the incredibly slow speed of light as it travels across the universe, which it seems really fast to us on Earth. I mean, it's almost instantaneous. But, you know, when you start sending light signals across interstellarly, then you're actually going to see that it takes a really long time. So, one reason that we may not have detected faraway civilizations from outer space is because we know, even from sending our own signals, that light intensity, such as radio waves, it decreases as 1 over the distance squared. So the further it goes, the less brightness you actually have of the signal. And so even in the next star over, I mean, if they were to detect a signal, someone would have to really be looking for it. And on top of that, you're going to need to subtract all of this background noise. So imagine that you have an incredibly weak signal, super, super weak, amidst, a really, like a wall of noise, essentially. And so that's a good reason that we haven't made any detections so far, any obvious detections, and why possibly, if we're sending signals out, which you'll find out later that we are, why an alien civilization hasn't found our signal and contacted us. There are a couple of different hypotheses also that deal with the Fermi paradox, and one is maybe their civilization is so advanced and they see us and we're not advanced enough for them to really bother with, right? Another one is that we aren't able to see another civilization because there's a thing called a Dyson sphere, proposed by Freeman Dyson, and this is a thing. It's a mega structure that surrounds an entire star, and it absorbs almost all of the energy coming from that star, so we wouldn't be able to even see it. So I don't. These are all interesting sort of philosophical viewpoints and reasonable debates to have on this topic, though we really don't have a lot of science to back on any of this up, right? But it's a good discussion. So far we don't have any evidence of life anywhere outside of Earth, right? But what would define an intelligent civilization? Is that going to be a tribal society, such as that we have seen in jungles on Earth? Or is it going to be more industrial? Like, is it something that you see if you look at, I don't know, a large city like Tokyo or New York, and we have all of this bustle and stuff? So is that an intelligent civilization? Or are we just not quite there yet? So, moving on from that, we have a man named Frank Drake, and he developed an equation that helps us sort of determine how many intelligent civilizations could exist in A, our galaxy, and B, the universe. If we just take a look at it, what we have is a probability. It's a number of possible technologically advanced civilizations in our galaxy, right? And so how do we find that? We take the rate of formation of stars in our galaxy, which we can figure out. We know that. We take the fraction of those stars with planetary systems. And so now with exoplanet data, like I had mentioned, we think it's roughly 1/5. So that's a further constraint. Next, we take the number of planets per solar system. That is something we don't know exactly, but we can make a reasonable guess. We take the fraction of suitable planets on which life actually appears. That we don't know, right? We only know that life exists on Earth. So that's up to anyone to plug this number in. We take the fraction of life-bearing planets on which intelligent life emerges. And again, we don't know that because we don't know even where basic life is yet. We will. Then we take the fraction of civilizations that developed a technology that releases detectable signs of their existence into space. So what does that mean? That's like us, right? We're sending radio waves, we're sending probes, we have all this stuff. So we're looking for civilizations that exist like that. So that's kind of what I was talking about in the previous slide. And then we multiply all that by the length of time that a civilization that exists like that has been releasing signals into space. And so you take all these numbers, you put them together, and you get some number of possible advanced civilizations, right? And I think the original estimate was around 100,000 million in just our galaxy alone. And so there was, of course, a lot of skepticism about this. And what Drake had done was he said, well, since everyone's like mad about it, I'll invert it. What are the chances that there is no advanced civilization that exists in our galaxy? And he found that there's one part in the current estimate with our constraints that we know is around 15 million intelligent life-supporting planets in our galaxy. Okay, next. How do we even find an exoplanet? How do we find one of these planets? Well, so we observe stars with probes and telescopes. And so what you're going to see is when you're watching a star, sometimes the brightness will actually dip. And I'm going to show a clip of that happening in just a second. I'll just go over a couple of other possibilities. Some stars actually flash. And what that will mean is as a planet is orbiting the star, the gravity around the planet bends towards the focal point of whatever telescope we're looking through, and we see the brightness increase. And it happens periodically, right? So we know it's in orbit. Direct imaging, that's a possibility. I think we've discovered one exoplanet with direct imaging. Doppler shifted light would mean a planet has a wobble. So the light is going to change. It's going to get more blue as it's moving towards you and more red as it's moving away. So if it's moving like this, that means that there's a planet in orbit around it as well. And so just to kind of illustrate the point of a planet's luminosity dipping, I have this video here that I'm going to play. So you see on the left there's light versus time. And as the planet transits in front of the star, the amount of light that we receive goes down, and then it goes back up again. Okay? Good. So be sure to join us for part 3 of our extraterrestrial life talk.